Hello again. In this lecture we're going to talk about integration by parts. Now if you'd like, you can freeze the video and read this definition for integration by parts, but I'm just going to go ahead and just tell you what we're going to have here. Now what we're going to be looking for is we're going to be looking for an integral that we can write in the form of u dv. And then once we determine what u is and dv is, then we can actually find out what du is, and from u we can find out what du is, and from dv we can determine what v is, and then we can rewrite that integral as u times v minus the integral v du, and then at that point we can actually integrate this integral. Hopefully, if it works out right, we'll be able to integrate this integral and finish the problem. So let's take a look at this integral here where I have x times e to the x dx. Now what I'm going to do here is I'm going to think of this as two factors. One factor is going to be x, and the other factor is going to be this product, e to the x dx. Now by doing that, that tells me that I can write the u will represent the x, and then the dv will be the e to the x dx. So in other words, this is u and this is dv, and so in other words, in the integral I have u dv, and that's what I need in order to make this work. Now in the result, I'm going to have to know what du is, and I'm going to have to know what v is. So let me show you how we can do that. If you go down here, I can do a little table here. Since u is just x, then du would be the derivative of x times dx. So that would just be 1 dx. And now since dv is e to the x dx, I know I can just integrate both sides of this. And when I integrate dv, I get v, and when you integrate e to the x dx, as I'm showing you here, you'll just get e to the x. Now I know it's really e to the x plus a constant, but we'll bring the constant in at the end. Now we're going to apply this formula. The formula for this, if you integrate u dv, which is what we're doing here, you'll get uv. So uv, remember x is u, and v we determined is e to the x. So there's your uv, and then minus the integral v times du. Now we know that v is e to the x, and we know that du is dx. So now we can solve this integral. Once we can solve this integral, then we can finish the problem. Now I don't know why I did, but I copied this again down here. So this is just the same thing I had up here, but when I simplify this, the x e to the x, that's already done, so you don't need to do anything there but just move it over here. And then all you have to do to finish this is integrate e to the x dx. And we know when we integrate e to the x dx, we simply get e to the x. And of course this is minus, so we'd have a minus there. So we'll put it all together. We have x e to the x minus e to the x, and then of course since these are indefinite integrals, you have plus a constant. Now this formula, integration by parts, is generally used when you have powers of x times e to the x, or e to some power, or when you have powers of x times a log or a natural log of x. So here, let me show you what I'm going to do here. This one, you might think, oh well, then you should just let u equal x, and then you could let dv be natural log of x dx. Well, the problem with that, it wouldn't be a problem here, because if u was x, then of course du would be dx, just like the other problem. But if I let dv be the natural log of x times dx, then I'd have to integrate the natural log of x dx, and I don't have a quick way to integrate the natural log of x. So I'm going to have to write, let me write this a different way, and I'll show you what I'm going to do. So what I'm going to do here, as you can see, I showed you here, I'm really going to think of this as natural log of x first. then times x dx. So that way, now I don't have to rewrite it, I'm just showing you this so you can see. I'm going to let the u represent the natural log of x, and then the dv is going to represent everything else, x dx. Okay, and then that'll work out nice for me there. So here I'm going to let, as I said, I'm going to let u be the natural log of x. Then du would be the derivative of that, which is 1 over x times dx. And then over here, I'm going to let dv be the x dx, so you can see that there. And then I'm going to integrate both sides so that I get v. And then if I integrate the x dx, I get x squared over 2. And again, I'll wait till the end to put the constant in. Okay, so now, remember this is the integral of u dv, where u is natural log of x and the dv is the x dx. And so that's going to equal the formula uv. So I take the uv, which is the u is natural log of x, the v is x squared over 2, then minus the integral of v du. Now remember, the v is actually x squared over 2, and the du is 1 over x dx. Now I can simplify this a little bit. So let me go ahead and copy this down. Remember, we don't do anything with this. We just bring it down. So we have, I'm going to rewrite it as x squared times natural log of x over 2. And then for this, I know that x squared divided by x is just x, and I can pull the 1/2 out of the integral. So if I pull the 1/2 out of the integral, I get minus 1/2 times the integral, and then I have x. So now we know how to integrate x dx, right? So I'll go ahead and bring my first term over, x squared natural log of x over 2, and then don't forget I have minus 1/2 times this integral, and then when you integrate x, you get x squared over 2, and then of course plus a constant. And then let's bring this down one more time, x squared natural log of x over 2 here, and then when you multiply minus 1/2 times x squared over 2, you get minus x squared over 4, and then plus the constant. And so now we have integrated it. So you really see what this does is it breaks it up into two terms, where one term is an integral that we can deal with. So that's basically how this is going to work. Now on some of these problems you might be able to do it multiple ways. Like right here, I'm going to let u be the 6x right here. So I'm going to let u be the 6x. That means that dv has to be e to the minus 3x dx, which is over here. Okay, but you know, you might be able to make this work if you switch that around. Maybe you could let u be e to the minus 3x, and then maybe dv could be 6x dx. Now I'm not going to check that and see if I could do it that way, but sometimes you can do it more than one way, or you can solve these more than one way. So let's get back to this. So if I let u be the 6x, then that 6x is u. And then let dv be the e to the minus 3x dx. Then I've got this in the form of the integral of u times dv. So if u is 6x, then du would simply be the derivative of 6x, which would be 6, and then times dx. And now here, if you integrate e to the negative 3x dx to get v, then that's actually going to be e to the negative 3x divided by negative 3. And you can actually evaluate this if you need to using a u substitution, but I actually give my students a little formula on this. If you integrate e to the ax, like I have here, then you always get e to the ax divided by a. So if I integrate e to the negative 3x, you'll get e to the negative 3x divided by negative 3. Okay, so now this integral should equal uv, so that would be, there's the u, 6x, the v is the e to the minus 3x over minus 3, then minus the integral of v, which is this right here, right? And then times du, which is 6dx. Okay, now let's clean this up a little bit. We know if we divide negative 3 into 6, we get minus 2, so that's where I'm going to get the minus 2 from. And then of course I went ahead and cleaned this up a little bit too, because -3 goes into 6, gives me a -2x, so I get a -2x e to the -3x there. And so then let's see what I can do next. Let's just bring this term over. So let's just bring this term over here. And then notice I have a minus here and I have a -2. Well, what if I factored the -2 out of the integral? Well, then I would have negative times a negative, which is positive, so that would give me +2 e to the -3x. Okay, so my last step would be to evaluate this integral, the integral of e to the -3x dx. And we already know how to do that. If you evaluate this, well, first of all, bring this down. So bring that term down, and then e to the -3x, if you integrate that, you get e to the -3x divided by 3, right? Or actually divided by -3. So e to the -3x divided by -3. And I just put the negative out front here. Now the 2 came from, remember I factored the 2 out of the integral, so that's where the 2 came from. So the 2 is right there. So the 2 came from here, and the -3 came from evaluating this integral, and I got the e to the -3 divided by the -3. And so now I have those two terms, and then plus the constant at the end. Okay, let's do one more here. So on this one, I'm going to, oh, here it is. I'm going to have x squared times the natural log of 5x dx. Now, I'm going to let u equal the natural log of 5x, okay? And then I've got a typo here, so I'll have to fix that in just a minute. Give me a second to fix this, clean this up for you. No, this is right. There's nothing wrong with this. Because when you take the derivative of natural log of 5x, what you get is you get 1 over 5x, then times the derivative of 5x, which is 5. So you get 5 over 5x, which is just 1 over x. So the derivative of natural log of 5x is just 1 over x. And then you multiply that by dx, and that's your du. Now the dv has to be the rest, which is the x squared dx. So you say dv is x squared dx, and then when you integrate this, you get v equals the integral of x squared dx, which is x cubed over 3. So now when you evaluate this integral, you have uv, which would be this natural log, times this fraction, x cubed over 3, then minus the integral of v du, which would be this fraction again, and then times du, which is 1 over x dx. Now, I'm going to rewrite this first term as just x cubed times natural log of 5x all over 3. And then on this one, I can factor the 1/3 out of the integral, so I'll put it on the outside. And then x cubed over x is x squared. And so now I have to evaluate this integral, x squared dx, which we know is just x cubed over 3. So I have this first term that I just carried over, and then I have minus 1/3 times the integral of x squared, which is x cubed over 3. And then when I multiply minus 1/3 times this, I actually get minus x cubed over 9. So that's where I get the minus the 9 from. So I get this first term here, and then the result of my integral, minus x cubed over 9, and then of course don't forget your constant right there. And so that's your so there's a few examples for integration by parts. And then here you have a couple of others that you can practice on if you want to, and practice on these and see if you can do integration by parts on these. Now this one you'll probably want to write it as, move it to the numerator and write that as e to the negative x. So that would be 6x squared e to the negative x dx. And then you can determine how to solve that using integration by parts. In the next video, I'm going to show you some definite integrals involving integration by parts, because these problems were all indefinite integrals because they didn't have any limits. So make sure you see the next video so that you can see the definite integrals.